Hi there and welcome to this video for Senior Physics on Light and Waves. In this video we're going to explore lens formula. Now as we looked at in our previous video we are able to draw accurate lens ray diagrams and determine the nature and the position of the image. However, we can use calculations to also determine what position the image is likely to be in and whether it's going to be virtual. From that we can also work out the height of that image. Okay, so the formulae is exactly the same as we had with our mirror formulae. We're going to be using the reciprocal formulae, which is 1 over f equals 1 over u plus 1 over v, where f is the focal point, u is the distance from the lens of the object, and v is the distance of the image from the lens. Okay, now the key thing to understand is that note down the bottom. This is the one that you're going to have to remember. Is that for convex lens, f is always positive, and for a concave lens, f is always negative. Noting that convex lenses produce real images and concave lenses produce virtual images. Okay, the negative being virtual in this case. All right, so as well as that, we can then calculate magnification factor and also the height of the image. Now remember, the magnification factor, just like we had in mirrors, is calculated by m, the magnification factor, equals hi, which is the height of the image, divided by ho, which is the height of the object, which can also be calculated by the distance of the image divided by the distance of the object. Remember, m is always a ratio, so it never has any units linked with it. Well, you should have had plenty of practice using these formulae, so what I'm going to do is just relate it to a lens diagram in a simple example that I've got here. So I've got a small 2 centimeter high candle is placed 50 centimeters in front of a 20 centimeter focal length convex lens. Find the position of the image, the magnification, and the height of the image. The position of the image of the candle is then placed inside the focal point at 10 centimeters, and we'll calculate its position there. Okay, so let's look at question 1. The position of the image when placed 50 centimeters in front of a 20 centimeter focal length convex lens. Well, I use 1 over v plus 1 over u equals 1 over f. I substitute in my values and rearrange so that I get 1 over v equals 1 over f minus 1 over u. F is 20, u is 50. Substitute in and solve the fraction, and then inverse 3 over 100 will then be 100 divided by 3, so v is going to be 33.3 centimeters from the lens. Noting that it's positive, so it's a real image. So the second one asked me to work out the magnification. Well, the thing is, I know my distance of my object and I know my distance of my image from question 1, so I can use my formula m equals hi over ho, which also equals v over u. I'm going to use the v over u section to find the scale factor. So it's 33.3, which is what I got for my distance of the image from my previous question, divided by 50. So my magnification, it is diminished, it's got smaller by 0.67. So question 3 then asked me to use this value to then calculate the height of the image. Well, I know that the height of the image was 2 centimeters. So again, I use the same formula, but in this case, I'm going to use m equals hi over ho, and I'm going to rearrange it so hi equals m times ho. So it's 0.67, which I got from question 2, multiplied by 2, gives me 1.33 centimeters tall. So with our height of our image has actually decreased or diminished. So I now know that it's real. It's 33.3 centimeters from the lens, and it has got smaller in size, 1.33 centimeters. Now the next one asked me to find the position of the image if the object is then moved 10 centimeters from the lens. So I used the same formula as I did in question 1, but you'll notice as I rearrange that I get a negative value. So I get a negative 10 centimeters from the lens, which means it's going to be on the same side of the lens as the object. The result is that the negative means that the image is going to be virtual. So it gives you an opportunity by moving your object to or from the lens, we're either going to get a real image or we're going to get a virtual image. Okay, well I hope you found that useful. So what I suggest you do is watch my other videos that I've done of some exemplary questions, and I'll try and make them so that you've got one using a concave, one using a convex, and as a result you can see where the little tricks are to make sure that you can get your answers correct. Well, I hope you've enjoyed this video, and thank you for watching, and I look forward to seeing you again.